Good morning. How are you? Hope you are all in the pink of health. I am Rai and you are watching Bond Making and Bond Breaking channel. So, the chapter is Haloalkane and Haloarenes. So, today's topic is preparation method of haloarenes. What I said? Preparation method of haloarenes. So, you came to know that this is addins. If you add a halogen, this is called haloarenes. We are going to prepare it. Okay, so you write, we take aniline. First we take aniline. This process is Sendmail process. This is aniline, NH2, benzene and NH2. This is aniline, and you used NaNO2 plus HCl. If you use it, what I said, NaNO2 and HCl. So the entire product is HNO2. Okay, so our main aim to use HNO2 with this combo pack. We get benzene diazonium chloride. This is the mother element, because from here we can prepare so many haloarenes group. Okay, because this is N2. N2 means nitrogen, and entropy helps to remove this nitrogen. Okay. Now the mechanism. Now the mechanism is, first we get ON and OH. This is HNO2. This is lone pair. Oxygen has lone pair. So what is this? This is HNO2. We write in this way. What I write? O double bond N, bond O, H, and O has lone pair. Okay. Then it reacts with H plus. And we know lone pair has tendency to attack the H plus. So it wants H plus. So the product is going to O double bond N, bond O, H, and H. As oxygen donates its lone pair, it shows positive charge. Okay, so we know that water is a good living group. So H2O is a good living group. So if we remove it, we get O double bond N, as it is plus. So ON plus. Okay, O gives its lone pair to the H plus and get H2O, and then remove it from this compound, you get ON plus. Okay, now you take this aniline. Nitrogen has lone pair. This lone pair attack this. Okay, this lone pair wants this group when you use it. So what's happened then? Then this is aniline, and you get NH2, that is NH and H, NH2, and then N double bond O. This is the process, and it gives its lone pair. Nitrogen gives its lone pair, so this nitrogen shows plus. Okay, is it clear? Then you get nitrogen as it is lone pair, hydrogen, nitrogen and its oxygen. Okay, we remove this hydrogen, so we get lone pair. A lone pair wants to make a bond, and lone pair goes here to make a bond. Then this pi bond, this loosely electrode pi bond, as it is broken, then the negative charge on the oxygen is occurred, and as it is negative charge, it attacks this hydrogen. So the product is N. It gives it lone pair, so double bond is occurred here. So double bond O, and then double bond is broken here. So the compound is O and it is H. So O and H. Okay, this is OH, and O has lone pair obviously. Then you can add it H plus. If you react with this H plus, this lone pair attack this H plus, and you get this N double bond N and O, H and H, this is plus. So OH2 is a good leaving group, therefore you get benzene and N2 plus. When it is react with Cl minus or Cl2 minus, you get N2 plus and Cl minus. This is the compound. Okay, let's see. This is aniline. What is this aniline? This is NH2 and this is benzene. So aniline, you used NaNO2 and HCl. You used NaNO2 and HCl. If you used NaNO2 and HCl, Na and Cl is removed. So HNO2 we get. HNO2 is the indirectly product which I get with this combo pack. So the product is benzene diazonium chloride. What is the mechanism? Mechanism is, first of all, this is HNO2. See, HNO2 we write in this way. O double bond N, single bond O, it has lone pair and H. Then you react with acid. Acid means H plus, and we know that lone pair has tendency to attack the H plus. So there is a lone pair, so it wants to attack H plus. There is a lone pair, so it wants to attack H plus. And lone pair, when it's attack the H plus, the formation is that oxygen donate its lone pair. Oxygen donates its lone pair. When someone donates its lone pair or someone who donates its electron, it shows positive charge. So as it is donate its lone pair, it shows positive charge. So the compound is, when O donates its lone pair to the H plus, it forms H and H, that is OHH, so H2O. And we know that N2 and H2O are the good leaving group. So H2O, as it is known to us that H2 is good leaving group, so H2O is removed from this compound. Okay, and we get ON plus. N release H2 removed from this compound, so it shows positive charge, so N plus shows positive charge. So the compound is O N, and N shows the positive charge on its head. So when you take this aniline, means benzene and NH2, when it takes this aniline, the lone pair on the nitrogen attack this N plus. Why? Because this N plus shows positive charge. Nitrogen has lone pair, so it wants to attack this H plus compound or ion. And when it attacks to this NO plus or N plus compound, it combines to it. So this is NH2, we write in this way NH2, this is NH2, and it attacks to this NO. So this NO is that. So NO is here. So this is the compound that we get. When N plus, so its tendency to snatch the electron from this hydrogen, and it snatches the electron. As it snatches its electron, what happened? The lone pair is here. So on the next period, lone pair donate to format a bond, and when lone pair donate to create a bond, the loosely bonded electron is removed from here and it shows negative charge. As it is shown negative charge, it attracts to the H plus ion. So the compound is N, lone pair is going here to make a bond. So N double bond N, and loosely bonded electron has broken. So the single bond is here, and it attached to this H plus. So O and H. So it is OH. So the compound is N double bond N, O bond H. As oxygen shows lone pair, and we know when it reacts with acid or H plus, it tendency to attack the H plus. So lone pair attack the H plus and it forms H2O. And we came to know that H2O is a good leaving group. So H2O removed from here and the N2 plus is occurred. So compound is N2 plus, and when it reacts with the Cl minus or the negative ion particles, it forms or it combines to create a compound. So the compound is benzene titanium chloride. So it is the simple mechanism behind this simple reaction. Hope you understand. Okay. Next. Now the Sendmail reaction is starting from here. What is the Sendmail reaction? The Sendmail reaction is if you use CuCl and HCl, you get chlorobenzene from this reaction. Okay, because nitrogen is a good leaving group. As it is, if you want to use a CuBr with the presence of HBr, you get bromobenzene. Okay, if you use heat, Ki and heat, you get iodobenzene. Or if you used HbF4 with HCl, you get fluorobenzene. And the side product, all this compound is nitrogen, as it is gas. Entropy helps to remove the gas from this reaction. So I know you have already understood that why this compound is called mother compound, because from here you can prepare fluoroalkane, iodoalkane, bromoalkane, chloroalkane on all the forms of haloalkane. If you use CuCl and HCl, you get chlorobenzene. If you use CuBr and HBr, you can form bromobenzene. If you use Ki and heat, you can form iodobenzene. And if you use HBF and HCl, you can form fluorobenzene. So it is very easy method to prepare all forms of haloarenes. Okay. Okay, let's go. Now you write Hans-Dicker reaction. But you write Hans-Dicker reaction. What is Hans-Dicker reaction? C6H5COOH. This is the benzoic acid. You want to use here AgOH. If you use AgOH, OH minus and H plus makes water molecules and Ag is added here. So the compound is C6H5COOH. Okay. Firstly, you prepare this, and then this C6H5 C6H5COOH reacts with the compound bromine, that is Br2, and remove this AgBr, and the product is Br. So the product is C6H5 C6H5COOBr, but CO2 is removed here due to CO2 is gas and entropy helps to remove it. So the product is C6H5Br, that is bromobenzene. This is the method which is given by Hans-Dicker. So this reaction is called Hans-Dicker reaction, or this mechanism is called Hans-Dicker mechanism. This is the short trick, not this is mechanism, but the reaction is Hans-Dicker reaction. What you use? You use benzoic acid with AgOH and you get this compound C6H5COOH. And this C6H5COOH reacts with bromine. This is Br and Br, and AgBr is removed and CO2 is removed due to the entropy factor. Carbon dioxide is a gas, so entropy helps to remove this carbon dioxide and you get C6H5Br. This is bromobenzene. This is very, very important. Okay. Okay. If you use 2RCOOH, okay, if you use it, the solvent is CCl4 and heat. Okay, CCl4 and heat. Now if we use 2 moles of RCOOH and reacts with I2, you get the forms of ester, that is 2RCOOR plus 2AgI. This is the another reaction. This is not Hans-Dicker reaction. Okay, so this is RCOOH and RCOOH. It reacts with I2. This is I and I. So the compound is AgI and AgI. Okay, so 2COOR is formed. 2AgI is removed from this equation. Okay, so RCOR and CO2 is removed from here, so 2 is not required here. So RCOR. This is the simple reaction when it reacts with the 2 moles of this compound. Okay. Okay. Now there are few preparation method of haloarenes. What are they? If you used benzene with the help of chlorine and you used FeCl3 with Fe dust, it reacts or you get chlorobenzene. It is also a simple process. Benzene reacts with chlorine with the presence of Fe and FeCl3. You get chlorobenzene. Okay. This is CH3 means toluene. It reacts with chlorine and same. You get 2 compound. One is major and other is minor. this CH3Cl and plus CH3Cl. This Cl in the ortho position and this Cl in the para position, on the para position. So what is the major product in here? The major product is this, because it the position in the 180 degree. So minimum repulsion is here and the maximum repulsion is here. So the major product due to this structure is this is parachlorotoluene and this is orthochlorotoluene. Okay. There is industrial method to prepare these haloarenes. Okay. If you want to form this compound on the industry, you use this equation. This is benzene. You use HCl as acid and obviously oxygen with the presence of CuCl2, and you get chlorobenzene. This is the industrial method. Okay, hope you understand. Okay, let's go. Now we are going to the properties, the rest properties. Some properties is the nature of C bond X is discussed already, and now we discussed about the physical properties of the haloalkane and haloarenes. Okay, let's go. And I give you the chemical properties on the next video. There are some chemical properties also which are very important. So physical properties, right? Physical properties. One is state. The state is mainly if the mass increases with the increasing of mass. With the increasing of mass, higher haloalkane haloarenes always liquid and gas, and lower haloalkane haloarenes is solid. Okay, sorry, gas. Just like if you CH3Cl and if you get CH3CH2 CH2Cl. So I say that the number or the mass, if we compare these two compounds with their mass, this compound has lower mass and this compound has higher mass. So there is a chance that it may be gas or it may be liquid. As the mass of this compound is low, so there is a chance that it may be gas. It may be liquid or solid, it may be gas. Okay. So CH3Cl, CH3Br, those are the gas. And those are the gas. And this is liquid or solid, this is liquid. So what I said, as chain increase, with increasing the chain, with increasing the mass increase, with increasing the mass, as the chain is going to increase with increasing the mass, the gaseous state is converted into or is changed into, with increasing their mass, liquid and solid. So number two physical properties are color. There is no color in the pure form, so it is colorless in pure form. So it is colorless in pure form. This is state. This is color. Second property. Third, smell. This is a order volatile and there is a sweet smell. Not all the haloalkane or haloarenes group but there are few mainly organic compounds, mm, aromatic compounds. Aroma means scent. So there is some haloalkane or haloarenes group which have sweet smell. Okay. And number four, melting point and boiling point. This is very important. Melting point and boiling point. As we know that van der Waals force of attraction is increasing with increasing their mass. So van der Waals force of attraction is directly connected with the mass. How? With increasing the van der Waals force of attraction, mass is increasing. Or with increasing the mass, the van der Waals force of attraction increases. As it is, with increasing the van der Waals force of attraction, with increasing the mass, boiling point is also. If we compare CH4 and CH3Cl, as the mass of this compound is high compared this compound, this has more mass, so the van der Waals force of attraction is more, so the boiling point is high. So CH3Cl has high boiling point. Okay, but the melting point is depend on the crystal packing. If the packing is good, if the packing is compact, so the melting point is high. Okay, next, branching is inversely proportional with the boiling point. If you have compound in this like chain like compound, and if you have branch like compound, the boiling point of this on the behalf of similar or approximately similar molar mass compound. Okay, the boiling point of this branch compound of branching compound, the boiling point is low. With increasing the branching point, boiling point decreases. Okay. Okay. There is another problem. If you have this compound, toluene, and toluene. Okay. We put the chlorine in the various position. One is ortho, another is. So the boiling point of this compound, the suitable order is ortho greater than para greater than beta. And the order of melting point is, as it is depends on the packing, and I know that the crystal packing of this para position is very good, so the para, then ortho, then this is very important question. Now the last topic is solubility. As you know that there is a formula like dissolves like. जैसी करनी वैसी भरनी. So like dissolve like. Okay, but there is a problem. CH3Cl, there is slightly negative, slightly positive, because this is a slightly polar compound, but it is insoluble. In water. Why? Because HO2, if you want to soluble, if you want to pack the haloalkane or haloarenes group in this water molecule, if you want to make it soluble in the water molecule, the required energy is so high. This is not possible for this compound. So it dissolved with non-polar compound as like CCl4, as like benzene. Okay, so it is soluble in this is insoluble in water, and this is soluble in CCl4 and benzene, this like of compound, or that's mean non-polar compound. It does not dissolve in polar compound, it dissolves in non-polar compound. This is the simple physical properties of haloalkane and haloarenes. ओके, थैंक यू, हैव ए नाइस डे। पढ़ते रहो, अच्छी तरह से पढ़ते रहो। बाय बाय, टेक केयर।